My first reaction is the Pummerer arrangement. The first thing we see in equation 1 is the Renaissance structure of sulfoxide. We want to break the bond between the sulfur and the oxygen and return their charges. In equation 2, we have an acyl group transfer. We see the Pummerer arrangement starts with an acylation of the chemical compound sulfoxide caused by an acetic anhydride, which gives us the acetate as a byproduct. product. But for the flow of electrons, we see that it's prompted by an anionic oxygen with a formal charge of -1, which is nucleophilic in nature. The ACO ion has a carbon group that is electrophilic in nature. So what happens is the negatively charged oxygen will attack the carbon below the double bond on the left, which leads to the formation of the isoxide sulfonium salt, which is in equation 3. We have an ionic oxygen in the intermediate acetate, which would be the driving force between the movement of electrons. The curved arrows coming from the ionic oxygen form a double bond, and the bond between the oxygen and the carbon will eliminate the acyl group. The byproduct of this is the isoxide sulfonium salt. For step 4, we have the formation of the sulfur substituted carbocation. This is formed from the ACO ion will abstract the alpha hydrogen, and the alpha carbon will be ionic, and the sulfur atom will have a formal charge of +1. This combination of having a negatively charged carbon atom, formal charge of -1, with a positive charge causes the formulation of an ylide. This gives us the equation on the left, named the acyl sulfonium ylide. The ionic alpha carbon causes a shift between the carbon and the cationic sulfur atom, and it leads to the creation of a double bond, and the bond between the sulfur and the oxygen break. This causes the elimination of all above the sulfur atom. For step 5, the formation of the alpha acyloxyl thiol ether. The equilibrium reaction is where we see the return of the carbocation, and then the ACO will act as a nucleophile and attack the now positively charged alpha carbon atom. This attack leads to the formation of the alpha acyloxyl thiol ether. And so that is the end of my Pummerer arrangement. And my second reaction is the Hofmann elimination. The Hofmann elimination starts with a primary methylation. The nitrogen atom uses its bond to form a methylation of CH3 and iodine. This nucleophilic attack allows nitrogen to pick up another bond, and it gives it a positive charge. In step 2, we see a secondary amine deprotonation, and in this step, positive hydrogen causes a secondary amine to deprotonate, and then nitrogen gains yet another bond. And then the second methylation is nitrogen will use this bond to attack again. In the process, the methyl group is formed and nitrogen gains yet another bond. Therefore, it is known as an exhaustive methylation because we keep going until nitrogen cannot produce another bond. In step 4, we see the formation of a catenary ammonium salt. In this step, the reputation of nitrogen nucleophile ends, and instead forms the catenary ammonium salt. Iodine would act as a counterion, but nitrogen no longer needs it to make a bond, so the exhaustive methylation also ends. In step 5, the last step, we see the formation of the Hofmann product. In step 5, we will react with a combination of Ag2O and water. The iodine has been here from the beginning, just getting deplaced by the methylation over and over. So it will be our mixture. The steric hindrance in the nitrogen plus and the trimethyl group is plentiful, so instead we don't decrease it, we just use the Hofmann elimination. And the flow of electrons then causes the removal of the entire nitrogen trimethyl group, otherwise known as the formation of a leaving group. The result is the Hofmann product and the formula of the nitro trimethyl group with the nitrogen bond returned. And those are the end of my 2 reactions.